This is the review for quiz 6.3 to 6.6 part 1. On page 474, number 30, this is a problem we ran across in the homework where they gave you this triangle with the given information and they wanted you to find the length of AD. So they want you to find this length down here. Well, in order to find the length of a side of a triangle that's not a right triangle, we're going to have to use either the law of sines or the law of cosines. But in order to do that, you need to know 3 pieces of information about the triangle. So if you kind of look at triangle CAD, you only know a side and an angle. We'd need to know one more piece in order to be able to solve for side AD. But this is what I want you to notice. Besides the fact that the picture is not drawn to scale, I want you to notice that this side is 12 and this side is 12. Making this an isosceles triangle, which means that this must also be 25 degrees because of this from geometry. So now this big angle up here is 50 degrees. Well, in the big triangle, triangle CBA, if this is 50 and this down here is 25, I'm going to subtract those from 180 to find out that this angle over here is 105. Well, now that I know that that angle is 105, now I can take this little triangle DAC. I know that this is 12, this is 25, and this here is 105. I can now find the missing side by using the law of sines. The reason I can use the law of sines is because I know a side and its corresponding angle. So the sine of 105 degrees divided by 12 is equal to the sine of 25 degrees divided by x. So now I'm going to cross multiply. The sine of 105 degrees is equal to 12 sine of 25. I'm going to put an x there because I forgot to. I'm going to divide by the sine of 105. So this goes away, and I'm going to find out that the length of x is approximately 5.3. The question I'm continuously getting is, how do you know where to round to? Well, in general, I'm going to round side and angle lengths to the 10th place, unless for some reason the given information in the problem is rounded to another place value, in which case I'll stay consistent with that. Problem 2 is located on page 474, number 38. A shortwave radio antenna is supported by 2 guy wires, 165 feet and 180 feet. Each wire is attached to the top of the antenna and anchored to the ground at 2 anchor points on opposite sides of the antenna. The shorter wire makes an angle of 67 degrees with the ground. How far apart are the anchor points? So I've drawn the picture here, and it said that the shorter side, which is 165, is the one that makes the angle of 67 degrees. Well, one of the things I'm going to do to help me out here is I'm going to call this triangle ABC. And I want to find side B. Well, remember that in order to find a missing side or angle in a non-right triangle, we use either the law of sines or the law of cosines, depending on the information I'm given. Since I'm given side-side angle, I'm going to use the law of sines. The sine of angle C over 165 is going to equal the sine of angle A, which is 67 over 180. What I'm doing is I'm finding angle C first so that I can find angle B. And then once I know angle B, I'll be able to find the side B. So 180 times the sine of C is equal to 165 times the sine of 67. I'm going to divide by 180, so this goes away. And then I'm going to take the inverse sine of this answer. And when I do that, I find out that C is approximately 57.5 degrees. Well, now that I know angle C, now I can figure out angle B by subtracting 180 minus 67 minus 57.5. And I find out that angle B is 55.5 degrees. Well, now that I know angle B, I can find side B. So I'm going to start with this same proportion, the sine of 67 degrees over 180, but this time I'm going to set it equal to the sine of angle B is 55.5 degrees divided by side B. Sine of 67 times x is equal to 180 times the sine of 55.5. Divide by the sine of 67, and I'm going to find out that x is approximately 161 feet. The reason I rounded this to the nearest place value is because the other two sides were as well. Remember, for these particular problems, you need your calculator in degree mode. So if you're trying to do it in your calculator and you're getting weird answers, check your mode first. Problem 3 is from page 481, number 39. To find the distance across a small lake, a surveyor has taken the measurements shown. The measurements are from him to one side of the lake, it's 2.82 miles. And from him to the other side of the lake, it's 3.56 miles. The angle between those two distances is 40.3 degrees. Find the distance across the lake using this information. So we want to find this distance here. Again, it may help for you to call this triangle ABC. Whenever you have side angle side, this is going to be the law of cosines. So the law of cosine says that side A squared is going to equal the sum of the squares of the other two sides minus 2 times the other two sides times the cosine of the angle between them. Sorry, I'm running out of space here. Remember, when you do this in your calculator, at the end of the problem, you need to square root your answer. You should get that side A is approximately 2.30 miles. And again, the reason that I rounded to the nearest hundredth was because those two sides of the triangle were also rounded to the hundredth place. We've spent a lot of time talking about finding the exact value of angles on the unit circle. When we do that, we're really looking at angles whose reference angle is always 30, 60, or 45, because those are our special angles. So in problem number 11, I want to find the sine of 150 degrees. Well, 150 degrees is in the second quadrant. Its reference angle is 30. So as long as you know that the reference angle is 30, we know how to find the sine of 30. Either you have it memorized or you revert back to the triangle here. So the sine of 30 has to be 1/2. And then you have to ask yourself, well, should the answer be positive or negative? Well, all students take calculus, and sines are positive in quadrant 2. Well, now let's try that again. In number 12, they want you to find the sine of 225. 225 is in the third quadrant, which means the answer is going to be negative. Its reference angle is 45. So in a 45, 45, 90 triangle, we know that the sine is 1 over the square root of 2. So you can either tell me it's negative 1 over the square root of 2, or you can tell me it's negative square root of 2 over 2 if you really want to rationalize it. But we've decided that you don't have to rationalize it. It's just a good idea to review that process for the purpose of the ACT. Number 13, the cosine of 210. So 210 again is in the third quadrant. In the third quadrant, cosines are negative, so we know the answer is going to be negative because all students take calculus. The reference angle, though, this time is 30 degrees. So what's the cosine of 30 degrees? Well, if I go back up here to this triangle, the cosine of 30 degrees adjacent over hypotenuse is the square root of 3 over 2. So it's negative square root of 3 over 2. Now let's go work with some angles that are in radians and with other trig functions other than your general sine, cosine, and tangent. I want to find the secant of 17 pi over 3. Here's the deal. Secant is the reciprocal of cosine. So if I know what angle this is, I know what quadrant it's in. If I find its cosine, I can just flip the fraction. Well, first of all, I know its reference angle is pi over 3, which is 60 degrees. So at least I know the cosine of 60 degrees is 1/2. What I don't know is the answer going to be positive or negative when I'm done getting my answer and flipping it. So 17 pi over 3, if you change it back into degrees, remember 17 pi over 3 times 180 over pi, will tell you is 1020 degrees. Keep subtracting 360 until you find its coterminal angle, which is at 300. That means that 17 pi over 3 is in the exact same location as 300. And again, we already knew its reference angle was 60. So the answer is that it should be positive. Now, this is the cosine. The secant is the reciprocal, so it's just 2. Next one, cosecant of 5 pi over 4. Well, the reference angle is pi over 4. And cosecant is the reciprocal of sine. So I know the sine of pi over 4, if I come back up here to the 45, 45, 90 triangle, the sine was 1 over the square root of 2. So its reciprocal is the square root of 2 over 1. But is the answer positive or negative? Well, what quadrant is 5 pi over 4 in? You can turn 5 pi over 4 into a degree measure, and you're going to find out it's the same as 225. So it's in quadrant 3. Are signs positive or negative in quadrant 3? All students take calculus. They're negative. One more time. Ooh, I just found out there's a limit to how far I can scroll this paper up. All right. Cotangent of negative pi over 4. Well, negative pi over 4 is in quadrant 4. And its reference angle is pi over 4. So really what I need to know is what's the tangent of pi over 4? What's the tangent of 45 degrees? Well, the tangent of 45 degrees is 1. But in quadrant 4, should the answer be positive or negative? In quadrant 4, it should be negative. But we don't want the tangent, we want the cotangent. What's the reciprocal of negative 1? The reciprocal of negative 1 is negative 1. So the cotangent of negative pi over 4 is negative 1. Problem 5, page 460, number 51. The cosine of theta is equal to negative 2 over 7, and the tangent of theta is less than 0. find the remaining trigonometric ratios of theta. All right, we had to first figure out what quadrant we're in because we need to solve our triangle so we know all three sides. Right now I only know two of the sides. I know that the side adjacent is 2 and the hypotenuse is 7, and since the hypotenuse can't be negative, the adjacent side must be the negative 2. But I also know that the tangent of theta has to be less than 0, which is negative. What quadrant are both cosine and tangent negative? Well, it turns out it's in quadrant 2. So here's my triangle. Here's theta. Adjacent, hypotenuse. I'm going to use the Pythagorean Theorem to find the missing side. Don't forget that when one of the sides is negative, please do not tell me that when you square it you get a negative, because you don't. You get a positive. That's one of the biggest mistakes students tend to make. Well, it turns out that y is the square root of 45, or if you really you gotta tell me it's 3 the square root of 5, you can. So I already knew the cosine of theta. That means I know it's reciprocal. I know secant is negative 7 over 2. The sine of theta is opposite over hypotenuse. So its reciprocal cosecant is 7 over 3 the square root of 5. Or you can tell me it's 7 the square root of 5 over 15, but you can leave it at that. The tangent is opposite over adjacent. And its reciprocal is going to be negative 2 over 3 the square root of 5. Or you can tell me it's negative 2 square root of 5 over 15. Whichever one makes you happier, but don't feel like you have to do more work than you do. Problem 6 is on page 468, number 38. It says a 96-foot tree casts a shadow that is 120 feet long. What is the angle of elevation of the sun? So I drew the picture. The tree is 96 feet tall. The shadow is 120 feet. The sun would be behind the tree, which is why it's casting a shadow. And the angle of elevation would be where theta is. Remember, the angle of elevation is from the ground on up. In order to solve this problem, all you need to figure out is which trig function to use, because this is just a right triangle problem. Well, I know opposite and I know adjacent. That means I'm going to use tangent. So the tangent of theta is 96 over 120. Theta is the inverse tangent of 96 over 120. And I'm going to find out that the angle of elevation is approximately 38.7 degrees. And that is the end of part 1.